All right, welcome back to the effect. We are still talking about difference in differences. Now, the big assumption that we talked about before with difference in differences that we have to assume is parallel trends. We need to assume that parallel trends holds in order for difference in differences to actually give us an effect that we are interested in. So to recall what parallel trends is it's the idea that, when we are doing difference in differences, we have some before to after difference for our treated group. We have some before to after difference for our control group, and we're going to subtract this difference out of that difference to get our effect. Under the assumption that over here, what we're seeing from before to after combines both the actual treatment effect we're interested in, but also sort of what would have changed naturally over time anyway. We are assuming that that second part, the part that would have changed naturally over time, is the exact same amount that it would have naturally changed over time in the control group that did not see treatment. We need to assume that those two things are the same. That is parallel trends. We are assuming that the before to after change, the trend is the exact same in the control group and what the treatment group would have been if the treatment had not occurred. So this is the big key assumption. We need to make sure that it is true, or at least we can't really check it directly, but we can try to make it as plausible as possible. We talked about how to make it plausible also in a previous video. But are there some things that we can do to check in the data whether we think parallel trends might be likely to hold in our particular sample? Well, there are a couple of things that we can do to support our parallel trends assumption. The first thing we can do, we already covered, in fact, in a previous video, which is to think through the context. Do you think that there's a reason to believe that parallel trends should be violated in this instance? Was something else happening at the same time? Do you have no reason to think that these two treatment and control groups would have evolved in the same direction? Right? Think through the context. We covered that in a previous video. But what can we actually check in the data? The most common thing that people do is they check the prior trends in the data. And this is something I mentioned briefly in a previous video, but we're going to think about how we can actually do that a bit more directly in this video. So what prior trends is you look at the pre-treatment data, the data that all came from before the treatment went into effect for anybody, and you check whether the control group and the control group and the treated group seemed to be trending in the same direction and at the same rate beforehand. That's the basic idea, right? If you are looking at math scores in a school that implemented a teacher training reform program and the school that did not, you might look at the years before that training program went into effect and see if the scores seem to be changing at the same rate in both areas. If they were, then that suggests they probably would have continued to change at the same rate in both areas, and that would tell us that parallel trends would be likely to hold, and the only reason we would see deviation from those trends would be the treatment itself, which is how we can pick out the treatment effect. How can we actually check for whether prior trends are equal? Well, obviously we have to have multiple periods of pre-treatment data, otherwise we can't get a trend before the treatment goes into effect, but if we do have that, there are some things that we can do. The simplest way to do this is with a linear regression, where we are regressing the outcome variable y on a set of group indicators, the fixed effects for group, and then we have a time trend, and we allow that time trend to be different by whether you are treated or in the control group. So notice here that time enters as in this case, linear variable, as opposed to a set of fixed effects as we did before when we were estimating difference in differences. But if we look at this, what do we got here? Well, we are estimating two different time trends. If we set group to 0, let's say that that's the control group, group 0, then we have a time trend. Every 1 unit increase in time is associated with a beta 1 unit increase in the outcome. That is the time trend for group 0. How about for group 1? Well, if we set group equal to 1, let's say that that is the treated group, then the time trend, every 1 unit increase in time increases y by beta 1 plus beta 2. So we have two different time trends, and we want them to be the same. We're hoping that they have the exact same slope, and that is what we want to check. So the difference between those two different slopes is beta 1 versus beta 1 plus beta 2, the difference being beta 2. So if beta 2 is different from 0, well, then that tells us that these two groups are trending differently over time. That's what we don't want to happen. So if we find that beta 2 is not 0, that is evidence against the parallel trends assumption. If we can't distinguish it from 0, then that is some good news. I mean, that's not, again, proof that we are definitely have parallel trends holding, but it is at least some suggestive evidence to help us out there. Now, a few notes on this particular procedure. Now, for one thing, I've used a linear time trend here. Notice that time just enters by itself. I don't have time squared or anything like that, but you can estimate the time trend in whatever way makes the most sense. If it looks like your trend is not linear, then you probably shouldn't use a linear time trend. Maybe add a polynomial in there and interact that polynomial by group as well. A second thing to note is that, failing to reject, let's say we're doing a hypothesis test, if we don't find that beta 2 is significantly different from 0, that's suggestive evidence that we have similar time trends, but you would also want to check it. If you only have a few periods of pre-treatment data, you simply might not have a lot of statistical power to reject that null of 0. So even if you did have different time trends, you might not be able to show it with a statistically significant test. And so you would want to do a good visual inspection, just like in this graph right here, to see whether it looks like these two things are trending together or apart over time. And that would be another good way of checking. Because again, anytime you have a test in statistics where you sort of want it to be non-significant, and in this case, we would like it to find a non-significant result, you have to worry, hey, do I actually have the statistical power to reject the 0 if indeed it's not 0? Because you might not have very good statistical power. That's something to think about as well. Just because you can't reject 0, even if the effect is meaningfully large, you still might want to be worried. Or if you see a visual difference in the trend, that would be another reason to worry. The third thing to think about when doing this approach is that this is a test of prior trends, whether the prior trends are different. Prior trends is not the same thing as parallel trends, which I understand is confusing. They're terribly named things that sound like they're the same thing, but they are not. Because it's entirely possible for parallel trends to fail, even if prior trends are the exact same. In the previous videos, I gave the example of, we have a teacher training program reform over here. Over here, we don't have that program. But at the same time, these guys implemented a free lunch program at their school. So if we looked before the treatment went into effect, we might say, hey, these are trending in exactly the same way. Prior trends hold, but parallel trends would not hold in that instance, because we would expect that even if the teacher training program had not gone into effect, the free lunch program probably would have made those two deviate from each other. So that is the most common way of checking whether prior trends holds, and in that way trying to suggestively say that maybe our parallel trends assumption is pretty likely. However, there are some other things that we can do. In particular, there are a number of ways that we can run placebo tests. Now, what a placebo test is anytime you set up a test that if your assumptions are correct, should give you an effect of 0 and a result of 0. So if you find a result that is not 0, that tells you that you've left something out of your model. We've done some placebo tests before in a number of different videos. In this case, what we're going to want to do is we're going to want to look to see if there is a difference in difference effect in a time period where the effect was not happening, or where the treatment was not happening. So for example, we've been doing our two four means difference and difference, or just doing our regular regression difference and difference. What if we drop all the post-treatment data, pretend that some other pre-treatment date is the real treatment date, and then estimate difference and differences again? We say, okay, you implemented your teacher training reform program in 2012, right? I'm going to drop all the 2012 and later data. I'm just going to use 2008 through 2011. I'm going to pretend that the treatment occurred in 2009, right? And then I'll say, pretending that the treatment occurred in 2009, do I find a difference in difference effect? Well, I should find that it is 0. If I don't find that it is 0, that suggests that maybe parallel trends is not holding, or at least prior trends is not holding there. That is an indication of prior trends failing, because we should see in a period where the treatment did not occur that the trends are exactly the same. If they're not, that tells us that the trends are different in a time when treatment is not occurring, which suggests that maybe in the time when the treatment is actually occurring, the trends wouldn't have been the same either. So doing a placebo test like that is another way to check whether parallel trends is plausible or likely to hold. There is another way of checking the placebo test and checking whether the effect is there in the pre-treatment periods that requires the use of a dynamic difference in difference model, which is something that I will talk about in the next video. But the same idea holds there. It's just a model that allows you to estimate the difference in difference effect in lots of different time periods at once, and you can check the effect that you estimate in the pre-treatment periods and hope that they are in fact 0, because if they're not, that suggests some violation in your assumption. All right, so those are a couple of different ways that we can support our parallel trends assumption. Now, none of these are going to be proof that parallel trends holds in any given context. All they are things that might be nice and suggestive. You do some gut checks. If they fail, it makes it pretty unlikely that parallel trends holds. And so if none of them fail, then, again, it's not proof that parallel trends is okay, but, you're probably, it puts you on the good foot at least, right? It makes it more plausible at least, and you can argue for your assumption that you need to argue for. All right, that is it for this video. Thank you.